Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macy, and today I'm interviewing Abhi Sivasailam about the different social and technical interfaces available for defining and enforcing data contracts. So Abhi, can you start by introducing yourself?
My name is Abhi. I head growth and analytics at Flexport.
And do you remember how you first started working in the area of data?
Yeah, it's been a winding road. So I started my career in the policy world, doing policy analysis, doing polling, really more on the statistical side. Went into management consulting after that, focusing on really Fortune 50 predictive marketing analytics, and then found myself in startup land as a data scientist. And that's where the through line became clear of the work I'd done so far, which is that most of the value I was creating, most of the value there even was to create with respect to data, I was really in that structuring of data. And so today, I still am involved in many data functions across the kind of functional landscape, the data science, the data analytics, et cetera, and also in other business functions like growth. But what I'm most passionate about is data engineering and data management, common through line.
And so, as I mentioned at the opening, the topic that we're covering today is some of your experience of working with the idea of data contracts. And before we get too far into that, I'm wondering if you can just give your working definition of what a data contract is and some of the goals and purpose of defining and enforcing contracts.
So for me, data contracts are guarantees on two things. They're guarantees on correctness, number one, and accuracy, number two. So what are those? Correctness is the data structured as expected? That means in a way that's consistent and also in some sense right. Is it an appropriate, is it a usable, is it a useful representation of data? So accuracy then is really two overlapping considerations. Number one, quality. Does the data reflect reality? Ontologically correct? Is a data generating process, is that stable? And two, semantics. When you say customer, does that still mean what you said it meant last week, a year ago, a month ago? And does it mean what I think it means? So data contracts are really a way of trying to enforce guarantees around this notion of correctness and accuracy.
And so in terms of the sort of contracts and the idea of being able to enforce semantics and correctness, there's a lot of gray area there because the sort of semantics and correctness are in some cases subjective where, particularly in the business semantics of, what does a conversion mean? Is it just when somebody fills out the form? Is it when they fill out the form and give us a credit card number? Is it when they have been a customer for 6 months? And so as you're going through the exercise of deciding what are useful contracts to define, sort of how do you deal with some of the fuzziness that comes in when you're dealing with these business level and semantic aspects of the types of sort of validation that you want to do on the information that you're working with?
Before we get there, maybe it's helpful to take a step back and talk a little bit more about the failure case here and, why we do contracts and why contracts don't happen by default. So What's the purpose here? The purpose of data contracts is to make explicit what's implicit. So the classical flow of data in most companies, kind of reductively looks something like, number one, an engineering team or some kind of data producer, they produce some new data or they change some old data as part of some, product development process. Number two, that data then lands in some kind of a lake, some kind of a, central clearinghouse. In that number two, the best case scenario is that, great, all the data that was produced upstream, it lands in that lake. The worst case scenario is that it doesn't, that some of that new data that's produced or changed doesn't even land and no one knows about it. Once it lands or doesn't land in the data lake, step three is basically that data is then processed somehow into data models, ML, dashboards, what have you, these data artifacts. And there, the best case scenario is, great, no breaking changes, everything is good, things flow seamlessly in with everything that we had before. The worst case scenario is there are breaking changes. There are breaking changes, and things that are being produced now are not compatible with things that were being produced before, and downstream artifacts are going to break. In practice, most data organizations, at least the ones that I've worked with, spend a lot of time dealing with the worst case scenario of both step two and step three. And this happens because in most companies, data is governed by implicit contracts. Data producers, which is generally domain engineering teams, simply don't know how data is used downstream. And so they can't possibly be expected to prevent those breaking changes. Certainly not in a way that wouldn't totally cripple their ability to define their own product, to evolve their own product in isolation. And, at Flexport, the company I work, we're a very operationally driven company. And what that means for us is we have, like many operationally driven companies, thousands and thousands of dashboards that are what I would call operational analytics that actually govern, hey, I am an operator, here's what I need to do next. That essentially represents, in a real sense, shadow product that is built on top of implicit contracts, these implicit contracts we're talking about. And what that means, and what that meant for us at Flexport, is product teams upstream will evolve their products as they should. They'll evolve their representations of data as they should. And because of these implicit contracts, because they don't have the context downstream, that leads to breaking changes. That leads to silent failures. That leads to highly brittle logic, thousands of lines of case when statements, et cetera, to patch together implicit versions of these implicit contracts over time. So that's really kind of the animating purpose here, which I think is helpful to ground when we think about kind of like what are we covering when we talk about data contracts. Well, it's not actually just, maybe the semantic entities that would govern, let's say, metrics. In many companies, in many contexts, in many even application domains, the notion of implicit contracts actually breaks production applications or production processes, which is a deeper problem yet. So with that, maybe I'll jump into a little bit of how we think about defining data contracts. So I'll talk a little bit about the conceptual, and then I'll go into maybe kind of technical implementation details. So starting on the conceptual, it's very important when you think about data contracts to take lessons from the microservices world. Now, the minute I say microservices, I've immediately lost half your audience, but it's important to recognize the minute you have a data system of any kind, you immediately live in a multi-service world, whether you like it or not. The minute you have some kind of data warehouse, some kind of lake, some kind of lake house, and you have a production system, even if it's just one production system, you immediately live in a multi-service world. And when you live in a multi-service world, you have good reason now to look at some of the tenets of what multi-service systems look like. And one of the key tenets of multi-service systems, and microservices in particular, is that you don't couple to the implementation details of another service, and you don't force other services to couple to your implementation details. This is really important. If in microservices you forced every service to couple to the database representation that another service uses, services can never evolve their databases, right? Which, of course, is absolutely crippling to product development. The very first thing to recognize here when you think about contracts, how we think about contracts, is to carry through on that service-oriented and that microservices tenet here, where we do not want to couple to those implementation details. Now, how do we approach that in a microservices world? The primary way is through a type of indirection, where services will have a layer of indirection between their internal representation of data, right? How I structure data in a database that I own versus my external representation of data. How do I expose data to the outside world, to the rest of the world? In SOA and microservices, typically this indirection is referred to as essentially a persistence model, how I represent locally, versus a domain model, how I can reason about my data, how other systems can reason about my data. And in practice, the persistence model can change often, will change often, right? I'm creating a new feature. I'm going to blow up my persistence model. I'm going to shard it, denormalize it or normalize it, or do whatever attempt to create caching layers. A persistence model will change. I might use a graph database today and a document DB tomorrow. My domain model should be relatively stable, should be more stable, because it should represent those more abstract, stable business entities, those business realities. So the very first step here to defining data contracts, the very first step here for me is to define what is your domain model. Domain by domain, service by service, application boundary by application boundary. What is that domain model? And in doing that, what I generally recommend and what we're following at Flexport is a domain-driven design paradigm. That's an approach that I think lends itself well to the data community. So what is domain-driven design? That's a topic in itself. The long and short of it, though, is for folks to consider. There's this notion of aggregates, entities, and value objects. So the example I often give is that of kind of a billing line item on a bill. In the billing line item, as a kind of a data concept, as a data entity, that is an entity. It's a thing, a billing line item. We would model that. We would reason about that as a thing. And that thing has properties. Those properties might be the dollar value. Those properties might be, the actual item name. Those properties are what we would refer to as value objects. Now, great. So we have a billing line item. That's an entity. We have these properties. That's a value object. The problem with looking at billing line items, though, is that billing line items don't make a lot of sense completely on their own. We can reason about them as a discrete thing in the world, but we would never look at just a line item in isolation. We would always look at it as part of a bill. And so enter the notion of an aggregate, which is that billing line items are parts of bills. And so when something happens to a billing line item, really what we care about is what happened to the bill overall. So this little digression into domain-driven design, into aggregates, entities, value objects is important, especially for us, because the way that we think about contracts is that 90% of the time, contracts should be based on the domain model, which means you need a domain model first. 90% of the time, the contracts that you have with other services, with data systems, is based on domain model. And typically, the interface between you and another system is that aggregate, right? When something happens to a value object, you basically expose the aggregate in total, and that's how systems can communicate to each other. There is a 10% kind of long tail as well, where even if you have a reasonable spanning set of these aggregates, you also sometimes need to throw in extra business logic, and so sometimes you'll need that extra business logic. But either way, that 90 and 10 together, that's the contract, right? That's kind of how we define a contract. The what of that contract then is everything about the structure of that aggregate value object and entity. So, what are the kind of the fields here associated with that aggregate and entity? What are those value objects? What is the semantic meaning of those value objects? What is the data type of those value objects as we send them? If our domain model has evolved, what is the version number? Is this the 5th time we've evolved this notion of our domain model? Is it the 2nd time? And what does that prior history look like? What did this aggregate look like last month, 2 months before? So on the conceptual side, and we can get into technical details, but on the conceptual side, this kind of long exposition is really, contracts are not as simple as, oh yeah, we need a stable reference. Contracts need a philosophy behind them for us. And that philosophy and that framework we borrow from the service-oriented world. And really thinking about how can we stably represent this notion of a domain model, decouple that from a persistence model, and then really bind our contracts to that domain model representation.
Yeah, the point about versioning is definitely very interesting because in the data world, most people think about that in terms of the schema of the Parquet file or the database table, et cetera. But to your point of the microservices analogy, there is more than just the schema information that you need to encode. And so you need to be able to understand what are all of the details that I'm committing to when I speak to this interface that is defined by this contract definition, and what are the things that I need to be able to treat as invariants in this communication. And so I'm interested in digging a bit more into the kind of types of information that you need to be able to encode in these contracts and some of the ways that that might manifest at both the technical and the social level?
Let's maybe start with the technical and then we can go to the social. The question of how we have this conceptual model, you have these aggregates, entities, and value objects. Now, how do you get that into a data system? So I'm long on one of the trends that I think we'll see more of in the coming years is a move away from simple CDC in data systems. Typically, most data orgs are still replicating. They're still coupled to the persistence model, right? They're still replicating databases. The paradigm I encourage folks to move to is more of a transactional outbox pattern. So technically, how we implement, this notion of these interfaces of these data contracts is we persist those data contracts into an outbox. A transactional outbox, very simply is, hey, I have transactions happening on my database side. When those transactions happen, before I actually close the transaction, write something to this outbox table. And what you write to that outbox table is your contract, is, in our case, the update to the aggregate, essentially, right? The rebroadcast of that aggregate. So why do I mention that? Because the notion of versioning here is really supported by the implementation details within that outbox. Specifically, what I generally recommend to companies is the outbox should contain representations of a versioned data format. So for instance, protobuf binaries. What do you write into that outbox? Well, if what you write is really that aggregate encoded as, let's say, a protobuf binary, then now you can do things that protobufs allow you to do, like version. You can have, version 1, version 2, version 3, et cetera, over time. And all of that semantic context, all of definitional context can be managed along with this evolving data format in that protobuf, and then can be governed and whatnot downstream. So what I really recommend to folks on the technical implementation side, and the approach that we're taking at Flexport, is the interface should be your domain model. That domain model should be essentially propagated out from an outbox, not from tables that you're CDCing from, but an outbox, which you can then CDC from if you like. We use Debezium for that at Flexport. And then if the way you encode that domain model in that outbox is in a versioned, evolving data format, for us, protobuf, then you can capture all of those semantic changes, you can capture all those structural changes, and you can allow consumers downstream to manage those changes gracefully as they listen to and consume those events.
And so this idea of the outbox as the sort of output from these source systems, that's definitely useful for the applications that you control where you're defining the data model. But how do you handle the similar situation when you're working with maybe third-party SaaS platforms and you're using a Fivetran or a Singer to be able to do the data extraction and then still being able to enforce the appropriate contracts of these are the types of records that I expect to be coming from this system. These are the formats that I want to encode it in to make sure that my downstream processing is going to be able to execute appropriately on them, and being able to then also maybe have some contracts about the volume of data that I expect in each of these batch runs or anything like that.
These third-party systems is, you're hitting on kind of a core problem that I think is more acutely felt for companies with a data footprint that's primarily from these third-party platforms. There isn't a good fix here because you don't have complete control of the domain model representation, but you do have some control. And, for us, the way we approach this dovetails on kind of the social aspect that you're talking about, which is, how do we design contracts? How do we help teams design contracts in a way that, speaks to, those downstream use cases? And for us, that is anchored on this role that's very important to our data ecosystem called the analytics engineer. So the analytics engineer, is, I think, been popularized by DBT and the Fishdown community. And I think our definition of this analytics engineer role is a little bit different than maybe how others look at it in the industry. I think the way it's often looked at is analysts that write SQL or analysts that, build data models and manage data pipelines. And for us, analytics engineers are, many things, but they're really this kind of core data modeling expert, this data modeling SME. We think of them as kind of the central hub of meaning making throughout the entire enterprise. How do we reason about the semantics enterprise-wide, the core concepts that kind of govern our business? The reason I'm saying all of this is coming back to your question here about Salesforce and NetSuite, et cetera. Well, how do we ensure that the Salesforce and NetSuite and the CRM, the ERP, the HCM have reasonably stable contracts, and those contracts are informed by downstream use cases? Well, we embed analytics engineers. So our analytics engineers are actually embedded widely into data producers. And this is key for us in making sure that this is the social part, right? Talked about the technical part. The social part that governs our entire contract apparatus is the role of analytics engineering. For all data producers, our goal is to have an analytics engineer that serves as data steward. And that data steward helps the data producers to collect context from data consumers and to bake that context in, to bake those users and use cases in upstream in a way that allows them to encode those users into those explicit contracts that are actually expressive and useful. And so the HCM, the ERP, the CRM all have an analytics engineer supporting them in how do we structure the data effectively for internal uses, but also external uses outside of those teams. And likewise with all data producers. All data producers have access to an analytics engineer that really specializes in the art and science of how do we structure data effectively? How do we make these contracts that are in turn based on domain models? How do we make those domain models really expressive?
Another interesting element of the idea of these data contracts, one of the things that you mentioned is that the kind of boundary layers are defined by your business domains. And so these are the points at which you want to define and enforce these contracts. But the actual enforcement piece is another interesting layer where you're mentioning that for this outbox pattern, you've got these protobuf schemas. But at the social level, where maybe you don't have a strictly technically defined mechanism for this handoff, still being able to at the social level say, I'm sorry, but I can't accept this piece of information from you because it doesn't adhere to these expectations, or I'm sorry, but you're not allowed to propagate that piece of information because it contains PII in it or anything along those lines, and just some of those aspects of enforcement at the social level.
Yeah, so that social level, everything about the social level, again, just comes down to this analytics engineering role. For us, this notion of data mesh at Flexport is unworkable without a central governance group. And that central governance group for us is that analytics engineer. How do we ensure interoperability between the contracts that are emitted from domain A and the contracts that are emitted or consumed by domain B? There needs to be some kind of governance layer, the procedural governance layer, social governance layer, and that is driven by analytics engineers that are a part of one center of excellence, but are matrixed into these different groups that then come together in these rituals where they say, hey, I want to expose, this new aggregate. Does that play well with, the ecosystem that, y'all are developing in this other domain? Does that meet the downstream use cases and the users of your domain? So they're really meant to be that kind of central meaning-making facilitator. And without that, it's really hard for me to imagine how, at scale, things like a data mesh or, even notions of a data contract would work.
This aspect of the data mesh is definitely something that is gaining a lot of attention and interest because of the fact that it does allow us to decompose these monolithic data problems into more bounded domains that we can manage and control in similar means of microservices, of being able to say this business team is responsible for these elements of information and they're responsible for defining and enforcing and providing these contracts and interfaces for consuming and providing data between these boundaries. And I'm interested in digging a bit more into the manifestation of contracts at those boundaries, where maybe I have an application database and so I want to provide data as an output to analytics consumers, and understanding what are the types of interfaces that are necessary to be able to make that consumable, and then maybe how that plays into the kind of platform layer of, as a product team, I have this information, I want to provide it to you. And at the sort of organizational layer, what is required from a platform capability to be able to make that a tractable problem?
So we simplify this problem. So, we take this notion of data mesh and, we simplify it in two ways to make it workable for us. One is we simply standardize the platform to Snowflake. I think Zhamak's original piece on data mesh embraces polyglot representation of the data, right? Some domains should be able to expose their data contracts in graph databases. Some should be able to do so in document stores or caching layers or what have you. And in our internal data mesh tenants, we explicitly reject polyglot presentation and standardize on, look, these are, relational SQL style tables that are all built, and all data products in the data mesh are built with one standard transform framework, which is dbt, one standard set of governance frameworks that are baked into dbt, and exposed in one standard platform, which is Snowflake. So for us, the data mesh is really Snowflake as a mesh of marts, where all of those different domains, those bounded contexts, have essentially their own marts, where there's kind of a data lake layer within each mart and a data products layer where they expose these domain data products, these data sets, these contracts. And then, our platform layer is much simplified. Every mesh consumer is consuming from the same place that they're also contributing, which is one of these marts.
With this ability to create these marts for these various data products, it does give that standardized interface. Before you settled on that approach, what were some of the other design choices that you played with to understand how can we create this platform layer to support this mesh concept and make it a scalable and maintainable solution? And also some of the requirements that went into your selection of a sort of common core data warehouse with these marts that are contained within that warehouse platform.
We considered essentially various virtualization options and API options. What you can think of as a kind of a basic virtualization option that I think a lot of organizations are contemplating is essentially a GraphQL layer on top of federated data stores. And that's a fine way to go. It just entails overhead, entails more management, more maintenance. For us, we were on Snowflake, we were using dbt. It's a standard that worked. It's a standard that was intuitive and easy to democratize and easy to maintain. That's the standard we ultimately landed on.
The other aspect of that is the sort of ergonomics of the solution, where, as you said, you're already using Snowflake, you already have some tooling around it. It's a fairly standardized interface. You don't necessarily have to do a bunch of custom application development to consume a GraphQL endpoint. You can just use SQL. There's a wealth of tools available for specific applications of that. And I'm interested in talking about some of the ergonomics of using data contracts in this method and some of the ways that they may potentially inhibit productivity and prevent the sort of free flow of information through the system. Of course, adhering to, issues of regulatory or compliance questions.
Yeah, so, I'll address that by talking about how we try and mitigate the impact on essentially developer productivity and the speed, the throughput by which new data gets into the mesh and exposed as a data product. There's two core things here. One, my favorite topic is, again, the notion of the analytics engineer. The analytics engineer here, too, is key. I think modern software development has gotten away from the core of what an application is, which is a UI on top of data. And frameworks like, model view controller are replete with this notion of, fat model, skinny controllers. Most of what an application is and most of where the logic is, it should be bound at the model level. And yet, most software engineers, most modern domain engineers aren't so focused or specialized or trained or interested in maintaining those data models. What they're incentivized to focus on and where the state of tooling propels them to be focused on is on maybe DevOps or other kinds of considerations. So placing an analytics engineer that is actually a specialist in thinking about the domain model right the first time allows us to accelerate how quickly we can assimilate new changes into that data model, into that domain model, and then push those changes downstream. So one key aspect of driving speed here, driving agility, is, again, that role of analytics engineer, absolutely crucial. The second is creating layers of indirection, right? And in the same way that we create a layer of indirection between the persistence model within a service and the domain model of that service, there are continuing layers of indirection as data enters and propagates through the data mesh. So the data is exposed from, let's say, the service, right? The domain model, emitted a contract. That data then lands in Snowflake. That lands in the corresponding, producer mart into kind of a lake layer. Well, there's another layer of indirection. On top of that, that data is processed into data products, another layer of indirection. And all of this indirection serves to allow the layers below to move more quickly. Because there are these layers of indirection above, we can insulate changes downstream, or we can insulate rather users downstream from changes upstream. So that's really how we kind of approach speed. One is through essentially this indirection approach where these are all layers of data that are stacked on top of each other and that allows lower layers to move quickly. And two, again, with this use of an analytics engineer to really build data models the right way the first time, which allows them to scale, and then evolve data models with the skill of someone focused on the art and science of data modeling.
Another interesting element of these contractual concepts and obligations is the question of security and access control and how you're able to either define what the expectations are or maybe defining in some of these interfaces what the regulatory burdens are within the confines of that business domain. And particularly then as you move into the data as a product layer where you're maybe presenting some of this analyzed information to your customers to be able to say, okay, in the case of Flexport, maybe we've analyzed all of the shipping logistics for this, naval route. And based on this information, we're able to predict that if you put a container on a ship in Hong Kong, it's going to reach San Francisco in X number of days. And, these are some of the, cost benefits of being able to use, this shipping line, for instance. And I'm just curious how you think about the security and access control implications of those different boundaries.
Yeah, security and access control is a topic that looms large in my mind. The simple answer here is I think of security in each mart as having two primary parties. One is a data owner and the other is a data steward. So the data owner tends to be, a product manager or, a business owner that's really accountable to the data generating process, whether that's an application or a third-party system or some other kind of offline process. They are typically steeped in the quote-unquote business requirements. They're typically closer to the kind of legal and security requirements, the practical concerns, and they set the access and authorization rules. Every data product that's created, every data product that evolves has these access and authorization rules. It can be exposed to these roles within the data mesh, these domain-based roles, these kinds of special users, these kinds of service accounts, etc. Who enforces then that does happen, that those rules are actually implemented? The data steward. And the data steward for each mart is typically an analytics engineer. In keeping with the data mesh philosophy, the analytics engineers aren't the only ones that are doing modeling in SQL and dbt and Snowflake. That is democratized to that whole domain, but there is still a steward that ensures the quality constraints, and in this case, the security constraints, and ensures those security constraints are actually implemented per the guidelines set by the data owner.
StreamSets DataOps platform is the world's first single platform for building smart data pipelines across hybrid and multi-cloud architectures. Build, run, monitor, and manage data pipelines confidently with an end-to-end data integration platform that's built for constant change. Amp up your productivity with an easy-to-navigate interface and hundreds of pre-built connectors, and get pipelines into new hires up and running quickly with powerful, reusable components that work across batch and streaming. Once you're up and running, your smart data pipelines are resilient to data drift, those ongoing and unexpected changes in schema, semantics, and infrastructure. Finally, one single pane of glass for operating and monitoring all of your data pipelines, the full transparency and control you desire for your data operations. Get started building pipelines in minutes for free at dataengineeringpodcast.com/streamsets. The first 10 listeners that subscribe to StreamSets Professional tier will receive 2 months free after their first month. In terms of the kind of biggest challenges that you've been facing in being able to understand at an organizational level how to define and adopt these contractual boundaries and then implement the technical requirements and build a platform that supports all of these interfaces, what are some of the biggest pain points that you've encountered and some of the ways that you've been able to work through them and understand sort of what are the trade-offs of each of these decisions?
So I think the biggest challenge is, we talk about data systems and this data mesh as kind of an analogy to service-oriented architecture. And one of the biggest problems architecturally, right, conceptually, not the implementation details, but kind of philosophically early on with SOA is if you define the domain boundaries incorrectly, you're going to have a bad time. And the same is true with data mesh. The same is true with, these kinds of bounded contexts that we developed in the data layer. If the way we think about bounded contexts is wrong to begin with, and the bounded contexts themselves are going to evolve rapidly, then this entire architecture that we built around those bounded contexts becomes a little bit more brittle. And there's really no way to completely solve for that. Fast-growing companies, and Flexport is one of them, a hyper-growth company that has evolved very rapidly and will continue to evolve very rapidly in terms of its business complexity, will face changing, shifting, bounded contexts. The biggest challenge for us going into all of this, thinking about these contracts, thinking about the interfaces between groups, is what should those groups be? And how to avoid Conway's law, for instance, and how we partition out these bounded contexts. So there's really no solve for that. Things will evolve. I would say, what we did was two things. One is we recognized that things will evolve, and where they need to evolve, we try and handle those evolutions first in the downstream layers of indirection, or rather the upstream layers of indirection here, which is just, we do it in Snowflake. We first and foremost, before we move the bounded context, in the actual service layer, we change them in Snowflake. We try and reason about, hey, there seems to be a lot of coupling. There seems to be a lot of overlap, between domain A and domain B. Perhaps we need to, reconfigure what these bounded context landscape looks like. And so we do that there, and that gives us kind of a safe place to play. This indirection gives us this opportunity to, have a two-way door in how we model in kind of a safe playground. And then we bring those learnings upstream, and then we jigger what the bounded contexts look like upstream. And the second approach is we just took a lot of time thinking about what those bounded contexts should be in the first place. You don't take that time, if you don't really think about what those domain models are and how they relate, all at once, you're basically setting yourself up for these models are going to evolve so rapidly that it's going to be very hard to keep up.
Another interesting element of these contracts in considering maybe the schema elements is how you're able to establish feedback loops where you say, at this point in the life cycle of data, I expect these records to be in this structure. And so in order for that to happen, I want them to originate from the generating system in this schema. And so now I want to build in some developer tooling so that anytime I'm generating an event from this application, I can validate as part of my CI/CD or maybe my linting checks to say that this structure is being applied and enforced properly, and that the semantics of the information are matching my expectations that I want them to adhere to at this downstream point in the lifecycle of that data. And I'm just wondering if that's something that you have been able to start to tackle, and any considerations that you have about how to manage some of that feedback loop in the full life cycle of data from the origination to the downstream system, and then as you're evolving that contract, having it feedback into the information generation stage.
Yeah, so feedback loops is something we think a lot about. I think this is a place where there's opportunity for better tooling in the space. Today, feedback loops are, two things. One, you already know what I'm going to say, which is, again, the analytics engineer, right? The key to the whole thing, of the biggest fanboy of this notion of this analytics engineer, where, they're embedded into these data producer teams, but their mandate is to look at consumption patterns downstream, to actually talk to consumers downstream, to be more of this kind of data product manager, so to speak, that's accountable for the quality and ergonomics of that product, right? So here again, analytics engineering. Two is, well, we should also support those analytics engineers with some kind of tooling to help them understand what those downstream use cases look like. And here they have essentially two options today, and we hope that this will get better over time. One option is, well, again, remember that a key part of our data mesh philosophy is tooling standardization. I explicitly reject polyglot presentation. I also explicitly and even more stridently reject a variety of transformation tooling. And so we've standardized on dbt. And so analytics engineers have very clear visibility in terms of models that are created downstream on what are those antecedent nodes that those models rely on. So anytime an analytics engineer has a data product in their domain that they're the data steward for, they can very clearly see this node, this product that we've created is the parent node to 1,000 other products, and here are those other products. Here's the transform steps along the way. I have full visibility into them. Now Now let me go and try and understand what those use cases, what those downstream transformations imply to me as the data steward of this domain, as the architect of this domain. And number two, we're also looking at, well, sometimes downstream use cases are not persisted as pipelines in dbt. Sometimes they're just consumption. I'm just writing a query. I just made a dashboard. And so we're also looking at essentially query parse and column level lineage based on usage to inform how are these data products being used and what does that mean for how they should be constructed in the future.
Working in the dbt space, I'm curious if there are any practices or specific technical implementations that you've been able to lean on to ensure that the different stages of the dbt pipeline are adhering to those different contracts as you propagate across those different business domains?
I think leaning on a couple of things is what I'd recommend to folks in the space. So the first thing I recommend to folks in the space is, I think you did a talk recently with someone on the column name contracts, right? I think that was Emily. And that is a fantastic approach. It's basically trying to create a strongly typed world within dbt and in Snowflake and SQL-based data models. Absolutely recommend that. If you can standardize on these kind of strong naming conventions as kind of pseudo-types, then those pseudo-types everywhere they exist will have the same level of guarantees. That's one thing I'd recommend. Beyond that, various packages to try and standardize on types of analysis, types of transformation. And then, of course, we also have the analytics engineer as that backstop for ensuring common governance standards, common implementation standards.
Own work at Flexport, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process of defining and building out this data mesh implementation and understanding how best to define and apply these contractual obligations between business teams?
I think the hardest part of all of this that I want to emphasize to folks is the importance, and people that have worked in microservices know this, the importance of domain modeling, the importance of, in the application footprint especially, really reasoning about your domain in a way that is reasonably stable through time. A well-designed domain model is a domain model that will be stable and be expressive enough that it can adapt to the variety of downstream use cases that people would ask of that domain model. So really putting enough effort into stress testing that domain model, I think is the biggest pain. I can't say that we've completely solved that either. It's a challenge that everyone that's ever worked in the service-oriented architecture will face. And that's what I'd impress on people as the hard part that's really important to get right.
For people who are starting to explore the space of data mesh and data contracts and business domain modeling, what are some of the cases where it's the wrong choice and it adds too much overhead and maybe they're best suited with just doing a more sort of ad hoc approach to how they manage these handoffs, or maybe just being a bit more, I guess, forgiving in terms of the interfaces that they provide and consume?
I think what we've talked about in terms of having data contracts as well as having the separation between a domain model and a persistence model, I think is never the wrong choice. I've talked to a variety of companies. I've talked to some earlier stage companies that have brought up, this sounds like a lot of overhead. Can I really commit to this? Can I afford to invest in this now? And look, having worked in a lot of early stage companies, I'd say early stage companies can least afford not to, because early stage companies are most likely to have explosive change in their domain models, explosive change in their persistence models that will completely wreck downstream use cases that are dependent on these implicit contracts. So I think there's never a wrong time to implement this. These kind of basic notions of, hey, think about what your domain model is, abstract that from your persistence model, don't couple to your persistence model, and try and reason about these data quantums in ways that are reasonably bounded and separated from each other. I would say that what will make it very hard is if you don't have specialists in the room, like analytics engineers. So if you don't have, as very early hires, if you don't have something like this analytics engineering role that can be more of that meaning-making central data specialist that specializes in structuring data models at every layer of the stack, right? Not just in SQL, not just in Snowflake, but also upstream. If you don't have that, things are going to be very difficult. So I would say never a wrong time, but if you don't have a role like an analytics engineer, that is the first thing I'd prioritize as quickly as possible so that you can start paying down these investments and avoid future tech debt.
As you continue to work with your team and evolve these domain models and expand on the investment that you've made in these contractual boundaries, what are some of the things you have planned for the near to medium term, or any particular projects or improvements that you're excited to dig into?
We're rolling out a data catalog, we're rolling out Stemma, and that's going to be integral to our enterprise use, successful use of the data mesh and the contents of Snowflake. What we'd like to expand on is the contracts that are actually emitted from the domains themselves being represented in the catalog. And that's something that we're looking at the best way to do that and to try and combine that with our catalog on Snowflake. Really, we want to make sure we have enterprise-wide visibility into kind of every layer of indirection along the data stack. So we want to start with that terminal layer, but really we want to move our way up the stack as well.
Are there any other aspects of the work that you're doing on data mesh and data contracts at Flexport, or the overall space of how to enforce these interface definitions in the data ecosystem that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I think there's two things here that are kind of open questions, open opportunities for tooling and technology. The first is what, in my talk with Scott Hurleman on his Data Mesh Radio podcast, he coined as data product marketing, which I think is a very important notion. So taking a step back, the notion of thinking of data assets as data products is easily one of the buzziest concepts in the space. It's probably the most attractive principle behind the notion of data mesh. And like all metaphors, it's really easy to over-apply this one, but I don't think we're at the point where we can over-apply it yet. The thinking is still relatively early. I'd encourage people to lean in. And what that means is, if data management is analogous to product development, what does that mean for how we work and what kind of functions we need to support the work that we do? And one place to start is considering product marketing. So when mature product orgs build product, they support those launches with product marketing. And we really need the same when we launch data products. This is something that I think data catalogs especially are really uniquely well positioned to do. How can data product owners best know all of those data downstream uses of their data products? How can we bake that feedback loop directly into a central tool? And when that feedback loop produces iterations that introduce breaking changes, how can we proactively notify those downstream users and get their feedback qualitatively, their active feedback, not their implicit feedback, right? Now, this is definitely something we're approaching with process at Flexport, but I think it's something tooling can help with. And at scale, and I think Flexport will reach that point soon, becomes necessary. So I think that's number one. Number two, I think, is really automated modeling. So AutoML was very buzzy 3 to 5 years ago, and that buzz has died down somewhat, in part because the benefits of ML, auto or otherwise, are sort of narrow. But that isn't the case for data modeling. And so the question is, how do we help data modeling scale, and how do we help those data modelers, those analytics engineers, how do we help them be higher leverage? And I think what that looks like is some kind of machine in the loop augmentation, machine in the loop modeling augmentation that becomes more automated. And here I think there's three things in the space that are, I think, interesting approaches. So the first is this notion of this entity layer. So Ben Stansel talked about this last week in his great Substack. And my take here on this notion of entity layer is that we're talking about modeling, we're talking about the importance of designing these contracts well, but company entities are remarkably standard across types of companies. And to me, the biggest source of inefficiency in thinking about defining these contracts or thinking about defining data models is arbitrary uniqueness. So one of my most strongly held beliefs about data, but also about just running tech companies, is there's only so many operator tactics. There's only so many operator models. It's a very bounded set. B2B is B2B is B2B. Two-sided marketplace is two-sided marketplace. And to the extent that that's true, what we can all really benefit from is a cross-company, right? Cross-company entity layer, contract layer that drives that standardization. So relevant to everything that we've talked about here, you can think of this as kind of a new type of contract layer where when your source system, whatever that source system is, whether that's a third-party source system or a proprietary source system, when your source system wants to represent a customer entity and you're a B2B SaaS company, you can do that however you want locally. You can do however you want from a persistence model perspective, whatever makes sense. But the minute that data then leaves your boundary, is exposed from your boundary, and it must couple to a contract standard that is reasonably universal, right? That isn't arbitrarily unique. And, the data space has tried to do this in the past. I think, there have been attempts with in a lackluster way with things like DBT packages, with Fivetran blocks, with LookML blocks, et cetera. But they're not really thinking about this contract layer. They're still thinking about this downstream, right? I think they have distribution wrong. And I think the right way to think about this is moving upstream and defining standardized contracts that services can actually couple to. That's part of kind of an open source and community-driven contract layer. So that's one way I think we can make modeling more effective, more efficient in a way that is really in keeping with everything we've talked about on contracts. And the last thing on the AutoML side is really, I'd love to see more by way of kind of introspection-based automated modeling. And we've explored some of this at Flexport. There's ways to introspect on the data that you just have within a domain or within an enterprise. You can look at what is the metadata of a table and what does that mean for primary and foreign keys and how do these tables join together. You can actually introspect on the data itself to try and infer join relationships. You can also take introspection further and you can introspect on query usage, right? This is something we're starting to do where we're looking at, well, how are people actually querying that data? And what does that mean for what new kinds of unions and joins and whatnot, what new kinds of aggregations we need to develop as part of our data models. And if you took this a step further, if you had this kind of introspection logic across companies, right? If this was a kind of like a tool across multiple companies, then in keeping with our notion of cutting down on arbitrary uniqueness, you could actually use introspection across multiple companies' query usage to inform standard ways of representing MAU, monthly active user models or customer models or what have you. So I think there's a lot of opportunity there as well. And we're starting to look at both of these. But I think for either of these to succeed, it would need, the open source, community-driven, and needs partnership from many more orgs beyond Flexport.
To that point as well, it's interesting to consider the role of things like the emerging metrics layer as a contractual boundary where you're moving from the data warehouse into these downstream systems. And so you're creating a contract around the semantics of things like, for instance, as you said, monthly active users. And to the point of the kind of third-party systems, another interesting potential direction that I'm sure would take a long time and an act of Congress to enforce is the idea that maybe these third-party systems generate some sort of like open metadata contract about these are the data models that we expose through our APIs where you're able to extract information to propagate to your downstream systems. And so that we have a much more kind of visible and clearly defined set of data models that we can work with from these upstream systems.
Yeah, what a beautiful world that would be. If there's any way to get there beyond an act of Congress, it's not going to be led by, isolated third-party tools. It's not going to be led by Salesforce saying, hey, we are going to, create this industry-wide or this rather cross-platform-wide entity layer. It's going to be led by the community. It's going to be led by demand. It's going to be led by data professionals that are standardizing on these kind of entity primitives that then these upstream systems can couple to, right? So I think that's what's really going to drive it. And I think we're early days, but we're very actively thinking about that. I'm very actively thinking about that and, would love to connect with anyone else that's interested.
Absolutely. Well, for anybody who does want to get in touch and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd be interested in getting your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think it is a lot of that data product marketing notion that we just talked about. I think a lot of it is that kind of introspection-based or entity layer-based auto modeling tooling. I think the third is, there's another way to approach automated modeling, which is another talk in itself, that is to do with knowledge graphs. So at Flexport, we're experimenting with knowledge graphs as a way to represent the realities of global trade. My take is that well-structured graphs as a structure, as a format, natively lend themselves to more expressive questions and answers, less modeling, and also, interesting ML-driven auto modeling approaches. So, one of the things I'm very interested in is also, tooling that democratizes the creation of those knowledge graphs, helping more companies create those knowledge graphs, and to also do so in part by helping maybe their non-graph databases also speak a graph. So I think that's the other thing I'm really interested in, and another hour-long topic in and of itself.
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you're doing at Flexport to dig deep into this area of data mesh and being able to model your data usage in these bounded contexts of the different business domains and creating and enforcing these contractual elements between them. It's definitely a very interesting and constantly evolving space. So I appreciate all the time and energy you're putting into exploring that within your organization and helping to share it externally. So thank you again for your time, and I hope you enjoy the rest of your day.
Cool. Great. Have a good one.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.